So you had seen hierarchical clustering algorithms, agglomerative and divisive. The agglomerative is to merge the clusters, and divisive is for dividing the clusters, right? Um, let me put that in this way. Okay, so let me just put this in this way, that agglomerative is basically merging, is for merging the clusters, and divisive is basically for dividing the cluster. Okay, so remember this, that you will get n clusters here, and you will get single clusters there. Okay, this is you have to remember. And the most important thing here, as we had seen in the agglomerative technique, the first step is to calculate the proximity matrix. And proximity, it means what is the similarity between two clusters, and how can you find that, right? So the question is, how can you calculate the similarity between the clusters, right? So this is the important question that arises whenever we are dealing with clusterings, or whenever we're dealing with clustering. Okay, so question is, how do we calculate the similarity between cluster? Okay, similarity between cluster, how can you find? So there are certain ways. So the first thing what you can do is you can use minimum min, this is the function you can use, min, max, these are the distances. You can also use something called as group average. You can use distance between centroids, and one more method is Ward method. This is Ward's. Okay, so these are the 5 techniques by which you can find the similarity between the two clusters. So let's understand one by one. So the first is min. Okay, so now min is, it is what you can tell about that. If I have I again need to change the color, so this is my color. So let's say this is my one cluster, this is my another cluster. Then if these are the data points here, actually if this is the data point here also, actually I have to remove this complete set of things. I again need to take another color, and let me just draw it over here. Okay, this way it looks perfectly fine. And if this is the point, so this min is basically the closest point, the point that lies in individual clusters. So what is the closest point in this cluster? uh, the closest point here is this one, and for this cluster this is the closest point. So I'm going to connect these 2 points. So if this is the C of I, and this is the C of j, then these are the 2 things that I am joining over here. So what you can do here mathematically, how can you write? You can write basically in sim of C1 to C2. This is my similarity function for cluster 1, cluster 2. So if this is actually I need to use another, let's say, actually I will denote this with L. Okay, L1 and Lj. So if this is my cluster 1 and this is my cluster 2, then this is the similarity function of C1 and C2. Then I can simply say that minimum of the minimum distance, the similarity distance between oh come on, between L of I and L of j. This is what I can write about minimum. So it is the closest point, the point that lies in cluster 1 and the other point that is lies in cluster 2, which are the nearest points. So Li and Lj are the nearest point by which I can join, and I can say these are the and by which I can say that these are the similar clusters C1 and C2. Okay, so I hope you understand. This is the min function that we had seen. The next is going to be my max, the max function. And max function is, from the name itself you can understand that if I have a cluster, I'm not going to take another another color, I'll take some time, so I'm just taking it here. So if these are the points, data points, okay, and so and if I'm using max, then you can simply say that the farthest point that lies in the cluster 1 and the cluster 2, I'm going to join that. So this is the farthest point, so I'll say this point is going to be my Lj, and this point is again going to be my L of I. Okay, this is the farthest point for cluster 1 and cluster 2. This is cluster 1 and this is cluster 2. So this is the farthest point that I'm joining over here. So you can see uh, I can mathematically write it down here in a very similar way, just like I did earlier. So similar, C1 and C2 equals to max similarity between L of I and L of J. This is how you can write for max function. So these are the two farthest point that lies in cluster 1 and the farthest point that lies in cluster 2, and I'm joining these two, and that's why I'm saying that C1 and C2 clusters are similar to each other. This is my second what you can say, the second thing, not the second thing, I mean uh, the second function for similarity index. Next is the group average. Okay, and so what you can say about the group average is basically you're taking all the pairs of point and compute their similarities according to the average. Okay, so I'm writing over here that I'm at the point of group average, and I'm saying that if I have this cluster, and again if I have this cluster, and this is C2 and this is C1, and whatever the point I'm having here, and let's say I'm just minimizing it, so I do not get the very bad image. So what I need is to average it. So to average, I have to join all these data points. Maybe I have to combine it, right? So this could be like this. You can do this like, and then you can point it over here, then you can join this thing, and this is basically very hard for me to draw it, but you can see that I'm joining all data point to all other data points for cluster 1, cluster 2, and so what I'm saying is take all data point and compute similarities, compute similarity, take all data points and compute similarity according to the average you will take, according to the average, you get. Okay, I hope you understand it. And mathematically how you can represent, let me just change the color and just show you that mathematically you can write sim C1 C2 equals to sigma. You're taking all the pairs, so you're taking sigma similarity of P of I and P of J, all the pairs. Okay, so it can be the Pi, all these points are Pi, and all these points here in these are Pj. So these are Pj, and all these points are in P of I. Okay, simply I can write, and it is going to be again divided because I want average, so that's why I'm taking C1 and C2. Okay, I'm multiplying it with the average, all the data points of C1 multiplied with this all the data points of C2. Okay, I hope you understand it. So this is the group average, and now let's understand the I think we are talking about distance between centroids. So this is my fourth, I think, point. So let's consider distance between centroids. So what do you mean by this? Distance between centroid means the, if I'm having, let's say if I'm having a cluster here, and if I'm having a cluster here, oh, this is very far, so let me say this is my cluster 2. So if I have a data here, 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 and here, and here also I have a data, then all these clusters definitely have some centroid. So let's say this is the centroid, this is the center location, this is the center part, sorry, the center point here. So these are the centroids. Okay, I'm going to connect these two centroids, and then I can say the you have to compute the centroids of two clusters and take the similarity between the two centroids, and then I can say these two clusters are similar to each other. Okay, and mathematically what you can I think mathematically I cannot show you, but you just have to compute the centroids. Compute the centroids of C1 and C2 and take the similarity. And take the similarity between two centroids. Okay, this is the fourth distance between centroids, and now we are talking about the last one. It is the the Ward method. Actually, I'm not very well aware about it, but the Ward method is very similar to that of the group average that we had talked about, where we take the average of all data points from cluster 1 and cluster 2, and then we can sum of the then we calculate the sum of the squares of the distance. Okay, so if you remember, so I'll just write it down here, Ward method. This is my fifth Ward's method. It's very similar to that of group average. Similar to that of group average, and let me just take some bright color here. Okay, so it is very similar to that of average itself. So I'll say similarity of C1 and C2. Then I'm going to take the sigma, and I'll say instead of similarity I'll take a distance of P of I, that is from the first cluster, and P of j from the second cluster. And I had to, as I told you, that it is going to be sum of squares of the distance, sum of the squares of the distance of P of I and P of j of cluster C1 and C2. Again, you have to provide this in the C1 mod. It's going to be multiplied with C2 mod. Okay, so this is the Ward method. I hope you understand it. These are the 5 different techniques by which you can find the similarity between cluster 1 and cluster 2. If you have any doubt, you can check me out on the comment section, and even if you can I mean you can mail me for that. Okay, if you have any doubt. So thank you so much for listening me. I'll be happy to help you if you have any doubt. Okay.